right. Good evening, mathematicians. So I'm making this video to kind of review and then, just mainly to review surface area and how to find it. Okay, so I know that the notes that we took before, right, on pages 15 and then halfway through 16, may not have been the most help, especially on this homework, the homework assignment, which is on page 19. So hopefully the notes today that we do will help you a little bit more. Okay, so that's why I am reassigning page 19 as homework once again, so that way you guys do get the practice that you need in order to find these surface areas. Okay, so I'm going to be starting on page 16 because there were a few questions that we didn't do. So in class together we did question 2, we also did question 3, so we should have those finished already. So I want to talk about question number 4 here. Okay, so just a quick review. Remember that surface area is it's the area of all of the faces, all of the sides of your three-dimensional figure, just added together. Okay, so when you work with a problem like number 4, right, so it says that the surface area of the cube is 150 square inches. What is the length of the side of the cube? Okay, so it's important that we know what we're trying to find here. So what is the length of the side of the cube? That's what we're trying to find. We're trying to find how long is this piece from here to here. Now the information that they give us is that the entire surface area. So when I make a cube out of this net that I have here, when I wrap, say, pretend I'm wrapping a present, when I wrap 150 square inches of wrapping paper around it, that's my surface area. Okay? So remember, when I'm adding the surface area, I am adding, or when I'm finding surface area, I'm adding all of the areas of each face together. So if you think about a cube, remember that a cube has 6 faces or 6 sides. Okay, that's important. That's an important thing for you guys to remember. So I'm going to say that when you add this area, so A stands for area, then you add the area of this face here, then you add the area of this face and this face and this face and this face, right? When you add all of them up, it should equal 150. Now, you're probably wondering, or you probably noticed, that all of these squares are the exact same size, and that is true because this shape is a cube, or this three-dimensional figure is a cube. So all of these areas are going to be the same, right? So if I rewrite this as like A plus A plus A plus A, right? If I rewrite this as this is equal to 150, another way of writing this is 6 times whatever A is. So 6 times whatever A is. Remember, A just stands for whatever the area of each square is. You should know that that is going to be 150. Well, how am I going to work backwards here? How am I going to find the area of every face? Some of you might have said, well, what if I just do 150 divided by 6? And then I would say that is exactly right. So let's see, 6 goes into 15 2 times, so that's 12. Subtract, so that's 3. So it looks like that every square has an area of 25 square inches. Now here's the part where you need to ask yourself, am I finished with what I'm supposed to do here? Well, let's reread the question. It says, what is the length of the side of the cube? Well, 25 square inches, well, the square inches tell me that it's an area, so I don't think I'm done here. So remember, I'm looking for the length of the side of a cube. And what do you guys know about the sides of cubes? Well, hopefully you said that the side of a cube, also the sides of a square, are all the same. So, when I'm looking for the side length here, I'm going to label this as S, okay? When I'm looking for the side length, right, you need to multiply that side times that side to find the area, right? So what number times itself gives you 25? Think about that for a second. Hopefully you came to the conclusion that 5 times 5 gives you 25. So I think what we can conclude here is that the side length, or the length of the side of the cube, is 5 inches. And that is our answer. Ooh, okay, a little bit of thinking there. All right, let's find the surface area of the triangular pyramid here. So we have a net, right? When we fold this net, it's going to create a pyramid, okay? So remember, the first step that we did when we were finding surface areas is we found which shapes are congruent to one another. So take a moment, pause the video now, and think about which shapes are congruent to each other, which shapes are the same size and the same shape. All right, so hopefully pause the video, and we color-coded the congruent shapes here, and it looks like all of these triangles here are congruent to one another. So all of these triangles sides are 10 meters long, and then all of these triangles also have a height of 8.6 meters. Okay, they all are the same. So when you're solving a problem like this, you could solve it in multiple ways. One way I'm thinking is find the area of each triangle, right? So find the area of each triangle, find the area of these 4 triangles here. Then another way is, well, couldn't you find the area of one triangle and then just multiply it by 4? I think the second one would be a little bit more. It would be a little bit more efficient, right? A better use of our time. It'll save us some time actually. So let's go ahead and find the area of the triangle. So the area of a triangle, that's what this stands for. A triangle. The formula that we use to find this is 1/2 base times height. Another way you could write it is base times height divided by 2. Okay, whatever might make sense to you guys, you can use that form. Okay, so let's see, it looks like the base of my triangle is going to be 10. Then I'm going to multiply that by the height, which I know is 8.6 meters. And then I have to divide this by 2. I know that 8.6 times 10 is equal to 86. 86 divided by 2 gives me 43. And I'm in, whoops, not square inches, but square meters. Okay, let me ask you this. Is this 43 square meters, is this the area of one triangle or the area of all the triangles? What do you think? Hopefully you remembered that this is the area of only one of the triangles. So remember, we know that there are 4 of the same triangles here, so what we can do, a little shortcut, we take the area of one triangle and we multiply it by 4. 4 times 3 is 12, 4 times 4 is 16, plus 1 is 17. So the total surface area of this pyramid here is 100, I keep writing inches, is 172 square meters. And there we go. All right, so I want you guys to, now that we've completed pages 15 and 16, I want you guys to go ahead and summarize this lesson. What did you learn? How do you go about finding the surface area of these types of prisms? Okay, so pause the video, take about 2 minutes, and summarize your lesson, please. All right, so we're gonna go straight into page 17 and 18. Okay, I'm gonna walk you through some examples, and this will actually look a little bit more like your homework, which was on page 19. Okay, so let's just dive right in. How do we find the surface area of three-dimensional figures? Well, the one way that I can think of is that's kind of the most straightforward is you're going to find the area of every face, okay? And when I mean face, I mean the sides of each of each side of a three-dimensional figure. Okay, so find the area of every face and then add them together. And we're going to take a look at what that looks like right now. So example 1. Here I have this three-dimensional figure. In mathematical terms, we call it a rectangular prism. But you guys might know the more common term. It's a box, right? So first thing you need to ask yourself is how many faces or how many sides does this box have? Okay, and what you can do is you can actually write them out over here. Write out what shapes do we have that make this 3D figure. So if you notice here, these 6 R's, right? This means that there are 6 sides and all of them are rectangles. Okay, now what I'm going to do is I'm going to advise you guys to draw pictures, okay? So what we're going to do is we're going to draw pictures of every face or every side of the prism. So that way you guys know that you're calculating the correct number of sides and you're calculating the correct surface area. Okay, so I'm going to do a little bit of color coding here. I'm going to start off with this rectangle here on the very front. Now take a look. What are its dimensions? Well, it looks like that base along the bottom, right, the bottom and the top, because it's a rectangle, is 8 inches, right? And then we need to think about the height. Well, if you notice that this over here is 2 inches, those two sides in orange actually equal each other. So the height of that rectangle is 2 inches. So my dimensions are 8 inches by 2 inches. Okay, now I need to ask myself, well, how many rectangles like this that are 8 inches by 2 inches, how many of them exist in this rectangular prism? There's one here on the very front, and you might have guessed that there is another copy along the very back side of this rectangular prism. It'll be kind of like there. Okay, so I'm going to draw 2 copies of it. Okay, so this is another 8 by 2. And there we go. So let's go ahead and calculate the area of these two. We use base times height for this formula here, so that's 8 times 2. So it looks like both of these rectangles have an area of 16. All right, let's keep going. I'm going to erase some of these lines here. All right. Another rectangle that I see is this here in purple. All right, and you need to ask yourself, what are its dimensions? What is the base? What is the height? Well, along the bottom of that purple rectangle, I see a 4, and then along the right side, I see 2. So it looks like this rectangle is a 4 by 2. So multiplying our base and height, we get 4 times 2 to get 8. And ask yourself again, is there another rectangle with the dimensions of 4 by 2? Yes, there is. It'll be over here on this side. Oops, actually it'll go down there. There we go. So I'm just going to draw another copy of it. And we know that 4 times 2 gives us 8. All right, and now we have one final pair of rectangles here. Erase some of these lines. There we go. All right, and the last rectangle we're looking at is on the very top. What are its dimensions? Well, you might have noticed that the base of that rectangle is 8, and the height of the rectangle is 4. And we know that the final rectangle is an area of 32, and we know that there is also one at the very bottom of this rectangular prism. So that's why there are 6 R's here. And this has the same dimensions. 8 times 4, whoops, it looks like a minus. That should be multiplication. What is going on? There we go. 8 times 4 is 32. And then, of course, we would add all of these things together at the very end to find our surface area. So let's go ahead and add these. 2 plus 2 is 4, plus 8 is 12, plus another 8 is 20. 20 plus 6 is 26, plus another 6 is 32. Carry the 3. 3 plus 3 is 6, plus 2 is 8. Looks like 112 square inches. Now, you might be thinking there's a little bit of a shortcut, right? Yeah, there is. So when we were finding all 6 sides or all 6 faces of this 3-dimensional figure, you notice that there are repeats, right? There's 2 of the same, right? There were 2 rectangles that were 8 by 2. There were 2 rectangles that are 4 by 2, and there are also 2 rectangles that are 4 or 8 by 4. And so what you could do is, well, you could just, honestly, you could just take the area of one of those rectangles. So we're going to add 16, then we're going to add 1, 8, right? One of the purple rectangles, and then we're going to add one of the pink rectangles, which was 32. So let's add these together. And then finally we get, well, let's see, 16 plus 8 is, actually let's do 8 plus 32 because then that gives me 40, and then 40 plus 16 is 56. 56 square inches. And then this kind of saves us some time, right? Rather than drawing out each individual little rectangle, right? If you guys know that there are 2 of each of these, well, what we can do is we can multiply 56 times 2, and we arrive at the same answer, 112 square inches. Okay, so we're going to try example number 2 with the shortcut. Okay, so let's go ahead and start finding our rectangles. I like to start with the front just because, you know, it's the first thing that I see, right? So in purple here, my first rectangle has the dimensions of, well, the base looks like it's 12, and then the height, it looks like I have the height over here, which should match, so I have a height of 3. So when I find the area of this side of this face, I get 12 times 3, which is 36. All right, let's find the area of this face here, or this side of my box. The dimensions of this box, I'm going to draw it over here to the side. The dimensions are, the base is 6 and the height is also 3. So when I plug that into my area formula, I get 6 times 3, which is 18. And then the very last face that I'm going to use is the very top, right here, or you could use the bottom. Okay, they're the same. The dimensions of this final rectangle, well, it looks like the base is 12, right? So the 12 is right there. And then the height of this rectangle is 6. So we're just going to do 12 times 6 to get 72. Now, remember, we're using our shortcut here. So what we're going to do is we're going to add all of these together. Okay, we're going to add these three faces together. 2 plus 8 is 10, 10 plus 6 is 16, so carry the 1. 7 plus 1 is 8, 8 plus 3 is 11, plus 1 is 12. So 126. Remember, 126 is not our answer here. This is not our answer. It's a step to getting to our answer, right? So our very last step, because, right, we're using our shortcut. Remember, we need to remember that there are 2 of each of these faces, or 2 of each of these sides. So we have to multiply by 2 here. So 126, well, when we multiply that by 2, 2 times 6 is 12, 2 times 2 is 4, plus 1 is 5, and then 2 times 1 is 2. So our final answer here is 252 square inches for the surface area. All right, I got one more example for you guys, and it's moving from a rectangular prism now to a triangular prism. Commonly known as the Toblerone box or Toblerone box, those of you who like chocolate. Okay, so first thing, find the congruent sides. Well, it looks like that these 2 triangles, one there and then one there, are going to be congruent. So let's go ahead and draw both of them. And we know that the dimensions are, the base of the triangle is 9, and then the height of the triangle, here, let me actually draw these a little better. There we go. That's much better, that's clearer. So the base of the triangle is 9, and then the height of the triangle, which is going to be inside, is going to be, it's labeled 6. So remember, I do base times height, 9 times 6, and then I divide by 2. 9 times 6 is 54, right? And then I have to divide 54 by 2. 2 goes into 5 2 times. Then we subtract, bring down the 4. 2 goes into 14 7 times. So we are at 27 square inches. And this triangle is congruent, so therefore the area is the same. All right, and now we have 3 rectangles. Now I know that some of the triangular prisms that we have been looking at, these triangles, or sorry, excuse me, these rectangles have been congruent to each other, but I just want to be safe and I want to double check to make sure that all the rectangles have the same dimensions, or, which is very possible, they might not have the same dimensions, okay? So let's bear with me, please. So I'm going to work with this purple rectangle over here on the side. Okay, so that's going to be my first R, which stands for rectangle. Now let's find the dimensions of this. So it looks like the base right here, the bottom of the rectangle is going to be 14, and then the height, well, the only number that that seems to be related to my rectangle here is this 8. So the height of my rectangle is going to be 8. So I'm going to multiply 14 times 8, because it's a rectangle, base times height. I know that 8 times 10 is 80, and 8 times 4 is 32. Well, what's 80 plus 32? Well, 80 plus 30 is 110, plus 2 is 112. There we go. So it looks like this rectangle is 112 square inches. Now, let's go ahead and find the rectangle that is on the back side here with this dashed line. Okay, what are the dimensions of this rectangle here? Well, it looks like the base of the rectangle, or the very bottom of the rectangle, is going to be the same length as the purple rectangle, right? So it's going to be 14, and then the height would be this piece right here. You guys can't see it now, but there was a black tick mark. So that must mean that the height of this rectangle is 8. So it looks like we have another 14 by 8 rectangle, which is fine, right? Like I said, we're just double checking to make sure that these 3 rectangles are in fact congruent to each other. Because yes, sometimes that happens, and an emphasis on sometimes, you guys, because it doesn't always happen. All right, let's take a look at this very bottom rectangle, our final side or our final face to our 3-dimensional figure. Okay, what are the dimensions of this rectangle? So I'm going to draw it here, laying on its side. It looks like the base is 14, and the height, well, the only number that corresponds to the green rectangle is this 9 right here. So here's one of those cases where the 3 triangles in the middle, or the 3, sorry, excuse me, I'm just all over the place with my shapes today. The 3 rectangles in the triangular prism are not congruent to each other. 2 of them are, and that's okay, but the third one is actually slightly different. So now we have a 14 by 9 rectangle. 10 times 9 is 90, 9 times 4 is 36, 90 plus 30 is 120, 120 plus 6 is 126. Let me just double check. 14 times 9, that's 36, 9, 10, 11, 12. Yep, 126 square inches. Okay, and are we finished? No, we're not finished, because the very last step would be to add all of these dimensions together. Let me bring this this 27 over a little bit so it's a little easier to add. Let me line these up. Let me line these up so my place values are in the correct places. Whoops. So let's move this here. Okay, now we're going to do some addition. And let's use a pink color. There we go. So I'm going to add all of these together. 6 plus 2 is 8. 8 plus 2 is 10. 10 plus 7 is 17. Plus another 7 gives me 24. So I carry the 2. All right, 2 plus 1 is 3. 3 plus 1 is 4. 4 plus 2 is 6. Plus 2 is 8. Plus 2 is 10. So I carry the 1, and then I have 1, 2, 3, 4. So it looks like the surface area of this triangular prism is 404 square inches. All right, you guys. So we've come to the point in the video where it is now your turn to practice. Okay. So what I want you guys to do is I want you to work in your groups. To answer questions 1, 2, 3, and 4. Okay? So remember, find the area of every single face or every single side of your prism and then add them up at the very end. Okay? If you guys are struggling with this, please come see me during RAM. I am very sorry that I am not there today, but don't worry, we're going to practice this, and then we're going to practice this some more, and then we're going to get into some volume, okay? All right, you guys. With that, I will see you in the next lesson.